Welcome back to physics, session 16 we're up to now, I think. So what I wanted to do in this one, I'm going to do two examples of the time graphs. Using the graphs, explaining motion, calculating things from them and so on. The best way to do this one is for you to grab a notebook, pencil, paper, your calculator, and let's draw it and work through each section by itself, right? And then you can get the logic that I am using with these. The way I approach them is, as I've said, I look at the time and I ask, what am I doing at A? What am I doing at B? And that actually answers what's happened in between. All right? So, if you like, just draw this one with me. All right? Let's just make sure I've got it. So what I'm going to do is I'm going to draw a velocity time graph that looks something like this, okay? And we say time here, and they've given us, this is an exam question kind of thing. This one's a bit longer than generally an exam question would be. Plus V up there, minus V up there, or down there. I made a little thingy here, okay? As I say, when you do these things, you know what, we're not doing art. They tell us that at time or point A, we are traveling at 5 meters per second. 5 meters per second at A. Then the graph slopes up here to coordinate point B, and that is at 10 seconds. And they tell us that that is 10 meters per second, right? Then it goes all the way across to C over there, and they tell us that that is at 20 seconds. Then they tell us that at 25 seconds, about say there, at 25 seconds at D, we've done that. Then they say on the next bit at 40 seconds, now mine's not to scale, but it doesn't matter, you know, seriously, okay, we say at 40 seconds, okay, my velocity was minus 15 meters per second. So let's just draw it across there and make that work. So that's at 40 seconds, 40, and this is at minus 15 meters per second, okay? And then this is joined up to that point there, and that is then labeled as point E. And they say, discuss the movement. Hopefully you've drawn it. So we've got an A to B going up, a horizontal line B to C, C to D quite steep down, and then from D to E going across at that angle. Obviously you can just stop the video and copy it down. And then we're going to start going through it and looking at it. Well, first of all, the way to do this, step one, okay, always have a look at this. Ask you, can you see that's after 10, 20, 25, and 40? Which means the time interval, remember we said we split them all up into discrete time intervals. The time interval here, delta t, is 10 seconds. Delta t here is going to be 10 seconds, correct? Delta t here is, I don't need to put in a double line, do I? Delta t there is 5 seconds. And delta t over here is 15 seconds, right? Just note, just for interest, we'll get back to it. Just note that what we've got here is BC is actually a rectangle. CD, that piece there to the line, is a triangle. DE and back to the axis is another triangle. We're going to be using the areas under those triangles very soon because that gives us valuable information. It's a quicker way without using the formulas to answer some questions, okay? You get the same answers, but it doesn't matter. It depends on which you prefer. Right, now they say, right, what is happening between A and B? Okay, so always label it. Keep a nice label and say, right, from A to B. Remember I say, my question is, what am I doing at A? Okay? At A, okay, that's the start. That is time 0. Right? That's as the stopwatch clicks. At time A, I am traveling traveling with a positive velocity of 5 meters per second. And traveling with a positive velocity of 5. You can choose. We don't know if that's up or down or east or west. But let's say that in the blurb they will tell you assume east or west, positive or negative, whichever. Let's say, here we say assume, okay, that direction there, okay, that direction east as positive. Therefore, we are traveling this way at 5 meters per second, aren't we? Here we go. Traveling this way at 5 meters per second, okay? This apple has really been around the universe. But we're traveling this way at 5 meters per second. So if I'm the observer, I click my stopwatch, zoom, there it goes past, right? At 5 meters per second. Then I watch it now. Then I say the next bit is at B. So let's have a look. At B, what is happening there? Right. At B, I say, what am I doing at B? Right, I read off. I look for the information. Go up. At 10 seconds, I am traveling east at 10 meters per second. So when I passed here, I was doing 5. Over here, 10 seconds later, I'm doing 10. What happened? I started to go faster. I started to go faster. What does that mean? I accelerated. Okay? I accelerated. Okay? Because I'm moving faster. Right. What do? We say, okay, what have we got? V initial was equal to 5. V final, meters per second. V final equal to 10 meters per second. And I've got delta t. I have, in this case, often in the formulas, I leave off the delta t. Just saves time, but you know, some places, some schools give marks for putting a formula down. I'm not sure why you're going to mark for putting a formula down that you're given on a sheet, but let's say it's the choice of the correct one. But I sometimes leave it off, so please be aware of that. So let's put in my delta t there, okay? Is equal to 10 seconds, right? Let's find a formula. Well, Vf equals Vi plus At. We're given 3, we need 8. So Vf is 10, 5 plus A times 10, correct? Why do I use the brackets? You'll note that every time I substitute in, I use a bracket. Why? I use a bracket very simply because if we have got negatives, I don't mistake it. I don't ignore, I don't forget a negative. You'll see in a few minutes when we do a deceleration, there's negative and there's also a negative displacement. Why? I can carry on, stop there and go zoom back that way, can't I? Right? So here we go. We say, right, therefore, we just move myself down a bit. Therefore, acceleration is 10 minus 5 over 10, which is 0.5 meters per second squared, right? Second squared. So now we know a lot about that motion, don't we? It's 0.5 meters per second squared is the acceleration between A and B. All right? Let us say later on we're going to do the displacements between these places, okay? And we're going to draw the position time graph. So let's leave those until last. Or do it now, doesn't matter. Let's say just for this one, let's do it here. All right. Okay, so the displacement is measured from the origin. The origin is where? The origin is where we start this. It's here. This is the origin. This is the start point. Okay? Everything happens after that point. Do you care what happened before? No. You're only given the information in 1, 2, 3, 4 time sections. Okay? This is what physics is. We split them into chunks of time. When you're splitting atoms in particle accelerators, you're working in millionths of a second. Some of those particles live for only that long, right? So, what are we doing here? We're splitting it into discrete time chunks that we can manage. Let's have a look, right? So, we're now working out distance. No, Kevin, not distance, guys. It's displacement. Yep. Displacement from origin. We cannot work out anything before that. We have no information to say what happened. We don't know where this particle came from. It just appeared on our screens and we tracked it from there. Right, so what do we do now? Okay, we say, right, displacement. Let's have a look. What's the formula? Well, delta x equals v initial t plus a half a t squared, correct? Well, let's put in, what do we know? Do we know delta x? No, we're working it out. V initial, yes, was 5 times time. Here was how many seconds, right? V times 10, it was 10 seconds, right? Times 10 plus a half. Now we've worked out a of 0.5, and that is 10 squared, right? Time was 10 seconds. Remember, we're only dealing with a to b. So let's have a look. That is 50 plus, let's have a look. That 10 times 10 is 100, divided by 2 is going to be equal to 25. So it's 75 meters. Right? Remember, we check always kilograms, meters, seconds. Everything must be in those units. Right, 75 meters from A to the east. Remember, displacement must have a direction. Okay? Magnitude, how far and which way. Okay. Well, there we go. So the displacement is 75 meters from the origin at B. Okay. Now, just out of interest, okay, I want you just to have a look here. Okay. I'm just going to shade in green. Okay. I'm going to take this as area A. What is area A? Well, it is a triangle and a rectangle, or it's a half the sum of the parallel sides times the perpendicular distance between them. It's a trapezium, isn't it? Well, half the sum, that's 5, 10. Okay? Half of 5 plus 10 times 10. Correct? Right. So if you do and you split it up, you could do it as a trapezium, or you can do it as a I've actually got it right here. I can work it out from here. So let's have a look at area A. Okay? Remember, sorry, this is my area A was a green A, right? It's area A. Okay? We said it was a rectangle, height 5, can you see that? Times 10. 5 meters per second times 10 seconds. Plus half base 10 times height, which is 5. Okay? Which is 50 plus half of that is 25, is 75 meters. Therefore, just make a nice red solid note here of this. We say the area under a velocity time graph gives us the displacement. Right? So instead of using the formulas, you could just take and work out the area. Okay? Same thing. But can you see the formula that we're going to be using in all cases over here for this is This is the formula. This is the graphical method. Okay? You get the same answer. Well, thank goodness for that, because otherwise Newton would have been wrong, and I don't think much of his work was. I'm open to correction. I mean, I really don't know his work, but I think he was a pretty clever guy. Okay? All from an apple. Now, not really, it was an inquiring mind, wasn't it, that made him do this. Now, let's have a look at from B to C. Go back to your graph, okay? What is happening at B? Ask, what am I doing at B? I am traveling. Let me see. Go and read. I've got a velocity. That's all I can say. Traveling east, because that was what we chose as positive, at 10 meters per second. Okay? Then I say, right, what am I doing at B? Okay. At B, traveling at 10 meters per second to the east. Well, hello. I mean, really? I'm traveling here at 10 meters per second and here at 10 meters per second, which means what? Am I going faster? No. Constant velocity. What does that mean? It means no acceleration. Acceleration. I think I actually used a double L a little while back. My apologies. My old English teacher would be having a complete cadenza about that. There you are. I've used a big word, so I've atoned for it. Two big words. Okay, no acceleration. Okay? Therefore, right, A is 0. Okay? Have I moved? Well, let's see. Let's keep using the same formula. Delta x is equal to v initial time plus a half a t squared. V initial, yes, I'm moving at, sorry, I'm said 25. I am moving at 10 meters per second, right? Plus a half of 0 times 10 squared. I am moving 10 meters per second times another 10 seconds, 100 meters, because this here is 0. Because I'm not accelerating, I'm not getting extra distance, right? Okay, let's work out the displacement, right? Okay. Well, we've got the displacement there. Sorry, I've just worked it out. So we can say that. Let's now go back to our green B. Okay, let's label it as B, shall we? Up at the top here again. Let's label this. Oh, come on. Let's label that as a B over there, shall we? Right? What is a B? Okay. B is the area B. Let's go and calculate area B. Area B is, it's a rectangle of 10, and the y-axis reads 10, so it's 100 meters. For those of you who want more, let's just have a look at something here. Okay? Well, what am I doing? I'm multiplying meters per second, the velocity, times a time of seconds, which means I get meters. Dimensional analysis. Let's have a look at the dimensions of this. It's going to be meters per second squared times time squared, second square, and I get meters. Okay? That's where it's quite useful using those little tricks over there. Right, so area B is 100 meters, isn't it? Okay? Cool. Now, so just as a matter of interest, where am I now? From A to B I traveled, I think 75, didn't I? And from B to C was another 100. So we are 175 meters away from our origin start position. Right, then now from C to D. Okay, C to D. I just say C arrow D, like that, right? Just to tell me what I'm doing. Okay, then I say, what am I doing at C? At C, I am traveling east at 10 meters per second. Cool. Next, what am I doing? Next, I am at D. What am I doing at D? At D, I am stopped. But in physics, we don't use stopped. We say V equals 0. What happened? At C, I was traveling, and the next minute I stopped. So therefore, I decelerated. Okay? Okay? Okay, so now what happens? Well, what do we know? Traveling at C would be V initial is equal to V final. V final is equal to V initial. Okay? V initial plus AT. V final was 0. Right? That's my final D, because D is after in time. And we always use final. So that's there is 0. V initial was 10 plus A, I don't know. And my time was 5. So therefore, A equals minus 2 meters per second squared. It's an acceleration. Let us look at the area C. Okay. Okay, let's have a look back on our triangle. This one's a triangle, isn't it? So this is going to be area C here, over there. So let's work out area C. It's half base times height. All right, let me just get back to, it's a little slower for me to get back there than you. Okay, area C is a half times base, which was 5 seconds, times height, which is 10, which is 25 meters. Okay? You as practice can go and work that out, delta x. V initial t plus a half AT squared. Work it out and see what you get. Okay? So therefore, what's happened? Okay? Lastly, between D and E, this is where the confusion arises, but don't. Just let's go back logically. D to E. Okay? By now you get the drift. I don't have to write what am I doing at D. I can just say at D, I am velocity is equal to 0. Now this becomes my velocity initial because I'm looking from D to E now. Remember, each time we move, this is going to happen in energy, in momentum, in all of these things. As we move, the final becomes the initial velocity now. Because from here to here, it was the final. Now it's the initial for the next session. Okay? And the final, they've given me is minus 15 meters per second. Which means what? It means, quite simply, that I have, well, I don't know, let's see. I'm going backwards, aren't I? Okay? Well, which means I'm going back to the origin, aren't I? I'm heading back now because I have stopped. Now that's a positive velocity, but I'm going this way. I'm going negative. I'm heading back to the origin at a velocity of 15 meters per second. So, hallelujah, let's have a look. What happens? Acceleration is going to be what? V final minus V initial over T, is it not? Which means V final minus 15 minus 0 over T was 15, which means minus 1 meter per second squared, right? And lastly, so I'm accelerating, okay? In other words, at 1 meter per second squared backwards towards the origin, okay? Let's go back and have a quick look and do the last area. The last area is area D, okay? I really hope you're doing this with me, okay? because when you relook at it and you're doing a test, this is a perfect example to go through. There are more in the test section, but this is a pretty good one. Okay? Right, let's now do area D. I hope I wrote D on my thingy, but anyway, area D. Area D is going to be a half base, which is 15 seconds times height, 15, right? Which is a half of 15. 15 times 15 equals that, divided by 2 is going to be equal to 112.5 meters to the what? To the, because it's minus 15 over there, isn't it? Minus 15, so it's minus 11 to the west, in other words. All right? Now, they say, right, draw an acceleration versus time graph. Okay, so how do I do that? Well, it's actually very straightforward. You've already effectively done it. You go and you redraw the key points. So we had 0, 10, 20, 25, and 40 seconds. Okay? Correct? That's what we had. What was happening? This is A and B. This here is acceleration negative and positive. Go back to the calcs. The acceleration between A was the origin and B was here, right? Is at acceleration of 0.5 meters per second squared. We actually worked it out, didn't we? Of course we did. Between 10 and 20, what were we doing? We were not moving. We weren't accelerating. We were at zero acceleration. Between 20 and 25, we were at minus 2 meters per second squared. Okay, if you go back, you'll see that. Then over the last bit, what did we do? The last bit we dropped to minus 1 meter per second squared. Minus 1 meter per second squared. Okay? Technically, if you've labeled your axes as a negative, that would be a 1 and a 2, wouldn't it? You wouldn't minus on a minus. You should automatically read it's a negative on that side. Unless they don't put in the A minus, then you put in the minuses. Okay? So we just read that off what we did. That's all we did. We read it off what we did, right? The next one, okay? This one I am going a bit over. I know that, but draw a position versus time. Heck, in other words, they want to know where are we, all right? Well, let's have a look. Position versus time. Hang on, we've got all of those answers already, haven't we? We know area A, area B, area C, area D, don't we? All right? So let's just go and have a look here now. All right? I'm going to just go and say position time. Well, therefore, let's just make a summary. A to B, what happened from A to B? A to B, from A to B, we did plus 75 meters. From, that's a B, by the way. B to C, all this we've calculated was 100 meters. Okay? So where am I from A to C? I'm 175 meters away. So we're watching this person. Let's draw it in this thing. Here's position A. Okay? How far is B away? Is 75. And there's another 100, isn't it? Then we said C to D, okay? We are slowing down, but we're still moving away at 25. Okay? That was area, I think, B, C, oh, 25, there we go. Can you see it here? 25, there we go. All right, area C was, but it's positive, isn't it? Why? Well, because think of yourself, right? You're traveling on a bicycle or a car or a motorbike or whatever, or running, and you start to slow down. Here I'm slowing down, okay? There I've stopped. Let's have a look again. Let's take the apple for a run, okay? Here we go, okay? And I'm traveling, I'm slowing down, slowing down, slowing down. I have still moved a distance. Remember the stopping distance problem? I've still moved 25 meters. So where am I now? Okay, I am another 25 meters away from home. Then I turned around and I went backwards 112.5 meters, didn't I? Right? So where's my final displacement? I am A, B, C, D, and at E. So therefore, we are the top way. I went out how far? I went out 200 meters, and I came 112.5 home. 200 minus 112.5 equals 87.5 meters from home. Right? That's where we are. Okay? I have gone over on time, but we've done one example and talked each through. Obviously, you're not going to get one example for 31 minutes, but we've explained it, we've gone through. I have got a couple more. I'll do those in the sections where we're going to do some exam prep. I'm going to move on to basically ticker timers now, and then we'll call it quits and we'll do some exam questions. Thanks for watching. Sorry again for going over time.